Hi, this is an installment of a series of videos where I solve the free response questions to this year's AP Statistics exam. This video has a solution to question 4. If you want to see the other questions, please check the description section below for all the links. Question 4. A medical researcher completed a study comparing an omega-3 fatty acid supplement to a placebo in the treatment of irritability in patients with a certain medical condition. 19 patients with the medical condition volunteered to participate in the study. The study was conducted using the following weekly schedule. Week 1, each patient took a randomly assigned treatment, omega-3 supplement, or placebo. Week 2, the patients did not take either the omega-3 supplement or the placebo. This was necessary to reduce the possibility of any carryover effects from the assigned treatment taken during week 1. Week 3, each patient took the treatment, omega-3 supplement, or placebo that they did not take during week 1. When you read a question, you need to make sure you understand what's going on, what the setup is, what kind of experiment they're conducting. If you read up to here and you get it, great. But if you did not get it, you need to slow down and maybe draw some diagram or something. For example, let's say that I don't get it. Then I look at week 1. Each patient took a randomly assigned treatment. Is either this omega-3 treatment or placebo. And then in week 3, they took the treatment that they did not take during week 1. That means the omega-3 people now take the placebo, and the placebo people now take the omega-3 supplement. And the part in between is so that the system have the time to wash the effect out. At the end of week 1 and week 3, each patient's irritability was given a score on a scale from 0 to 10, with 0 representing no irritability and 10 representing the highest level of irritability. So at the beginning, they get a score. At the end, they also get a score. And the score is 0 is good and 10 is bad. For each patient, the 2 irritability scores and the difference in their scores, placebo minus omega-3. So it's always placebo minus omega-3. For the blue people, it's subtracted this way. And for the red people, it's subtracted that way. Always placebo minus omega-3. What does this difference mean? If everything works perfectly, then the placebo have no effect, and the omega-3 totally cure the person of irritability. That means with the placebo, the score will be whatever it is, let's call it X, some positive X. But with omega-3, assuming it works perfectly, it should go all the way down to 0. So you go X minus 0, you end up with equal to X, which is a positive number. For example, you could start out with maximum irritability, and omega-3 cures you. 10 minus 0 is equal to 10, which is a positive number. So if the omega-3 works, the difference in scores should be positive. The results are summarized in the table and box plot. So you have all of this table and the box plots. I hope you realize now that this is a matched pair situation, also known as paired data, also known as mean of differences, where we look at the difference of placebo minus omega. We really don't care much about these. This is what we want. This box plot is what we want. Next page. The researcher claims the omega-3 supplement would decrease the mean irritability score of all patients with medical conditions similar to volunteers. Is there convincing statistical evidence to support the researcher claim at a significance level of alpha equals 0.05? Complete the appropriate inference procedure to support your answer. So this is a typical, straightforward, no tricks hypothesis testing question involving matched pairs or mean of differences. where we're given that the difference is D equals placebo minus omega-3. And we're testing that this mean is positive. Since we're testing that the mean difference is positive, the H naught is that mu sub D is equal to 0, and the HA is that mu sub D is greater than 0. Now we need to check conditions. This hypothesis test of the mean of differences is actually a one mean test in disguise. So it adopts all the conditions of the one means test. The conditions are number 1, randomness, and number 2, normality. For something like this randomized experiment, where there was no sampling, no random selection, there's no 10% to check. So we don't check the 10% condition for this. There is randomness because there is random assignment between pairs. That's how randomness is done for matched pairs. This condition is met. And number 2 is normality. N is 19, and that is less than our usual cutoff of 30. So we have to look for normality somewhere else. And the place where you can look for it is in this box plot. It is kind of symmetric, kind of not, but close enough. This condition is met, and we can say that all conditions are met. So now we do the test. On the AP, when you run a hypothesis test, they need you to identify the test by name or by formula. Well, then you flip over to the formula page to see if you can copy a formula. And you don't see anything involving the t-test. You give up on that idea, and now you have to identify the hypothesis test by name. The name of this test is a matched pairs t-test. And one thing I advise people to do if you have time is to put in the input. For a hypothesis test, the AP always requires both the test statistic and the p-value. This p-value is less than 0.05, so we reject H naught. That's the end of the calculation. Now the last step is to write the conclusion in context. When you reject H naught, then there is sufficient evidence that HA is true. I usually write there is sufficient evidence, but in this question, they use specific language. So I might as well use their specific language. And then the language that follows this spot should be an English translation of the alternative hypothesis HA. Fortunately, that English translation is in the question, so I might as well copy that as well. Of all patients with the medical condition. This word all here is actually important. It indicates that the conclusion is about the population, not just about the sample. Well, that's question 4. If you want to see my solutions to other questions, please check the description section below for all the links. Any comments, questions, feedback? If you think I was learning something, please do leave a comment below. Like, share, and subscribe for more contents. And thanks for watching. Bye.